So today we're going to be doing logarithms. Okay, so today is the introduction to logs. All right, today's actually going to be broken up into two separate videos because they're just a tad bit long, but they're really not that long. So first of all, logarithms. What logarithms are used to do is to solve exponential equations where a variable is in the exponent. Okay, so you can convert exponential equations to logarithmic equations, and then you can also do logarithmic to exponential equations. I'm going to show you how to do that now. Okay, so this is what a logarithmic equation looks like. And the way you read this is in your notes. It says log base A of x is equal to y. Okay, so what we're going to be doing is two things. One, showing you how to make a logarithmic equation into an exponential. And then we're going to show you how to make an exponential equation into a logarithmic equation. So first, logs of exponents. So we're going to do what's called the swoop method. We have this man with a giant hammer. He's going to swoop in. He's going to smash the log. The base of the log goes over to the other side, becomes the base for the exponent of y in this case, and that equals x. Okay. So let's show you how this works with other problems. We have log base 3 of 9 is equal to 2. We have our big man with his hammer. He swoops in. He smashes the log. The base of 3 becomes the base for the exponent of 2 on the other side. This does make sense because 3 squared is 9. That's a true statement. Okay. Now in this case, we have log base, I don't know. Okay, so this doesn't have a base, but all logs that don't have bases are automatically put as base of 10. So we can write in a 10 for the base. So if you see a log that doesn't have a base, it's automatically 10. All right, so it works the same way. He swoops in, he smashes. The 10 base goes to the other side, becomes the base for the exponent of 3, and 10 to the third does equal 1,000. There's another type of log. This is called the natural log. Okay, so we still have our man. And a natural log's base is the letter e. Okay, so the e works just like a variable that has a number associated with it, which is a lot like pi. So pi is 3.14. E is 2.718. So you can find this number, this letter, on your calculator. It is above the dividing sign on your calculator. So if you were to hit second to divide, you would come up with E. So you could use that in your calculations. All right. So the swoop method works the same for natural logs, which are these LNs. Swoops in, smashes the natural log. The base of E becomes the base of the y exponent on the other side, which equals x. Here we have another natural log. Again, it has a base of e, which again is 2.718. It's actually longer than that, but we're just cutting it off like we would for pi, 3.14 versus what it actually is, which goes on forever. So we smash the natural log. The base of e goes to the other side and becomes the base for the exponent of 2, which equals x. Now you can actually find out what this is if you squared the e value in your calculator. It would give you an actual value for x. Okay. All right. So what I'd like you to do is you've seen a bunch of different examples for converting logarithms to exponential equations. There are 4 more below, so 5 through 8. What I'd like you to do is do those and then also solve the resulting exponential equation for whatever x is. Okay. So try those 4 things out. Pause the video. Come back when you're done with those 4, and then start it up again, and we'll see how you did. So hopefully you're back after pausing the video and trying 5 through 8 out in the notes. So the first one, we're going to smash the log. The base of the log goes over to become the base of x. So 3 to the x power gives you 9. What is x? X is 2, so 3 squared is 9. The next one, smash the log. The base of x becomes the base of the exponent 2. So what squared equals 4? Well, 2 squared equals 4, so 2 is equal to x. Okay, the next one, because there is no base, we can put it as a 10. So we go smash the log. The 10 goes the other side. So 10 is now the base for the exponent of 2. And what is 10 squared equal to? Well, 10 squared is equal to 100, so x is equal to 100. The last one, we have a natural log. So we swoop in. Okay. We smash the natural log. The base of e goes over to the other side. And you can put this in your calculator. If we did e to the 5th power, which equals x, x would be 148.41. Okay, 148.41. That would be your answer for x, because you can actually find out what e to the 5th is. All right, so we've converted logs into exponential equations. Now we're going to go the other way. We're going to take exponential equations and write them as logarithmic equations. Okay, so I'm going to do a couple of these and then have you try some. So the first, what you do for these is you're taking pieces. So you have log, your base is the base in your exponential equation. Okay, the answer to the equation, z in this case, is the of part for your equation, and the answer for your log base 3 of z is the exponent, a. Okay, so that's where all the stuff goes. So this becomes your equation. Log base 3 of z is equal to a. All right. Next one, we have 100 equals x to the 4th. Again, the base of your exponent becomes the base of your log. The answer of your equation becomes the of part of your logarithmic equation. And the exponent becomes the answer of your logarithmic equation. And there you go. Okay, because this exponential equation has an e in it, you know it automatically has to be a natural log, because all natural logs have a base of e. So we can write our natural log. The e is the base, the 4 is the of, and the y is the answer. Okay. Last one. Oh, by the way, you don't have to write the base of e for a natural log. It's assumed it's there, just like how if you have a log problem with no base, it's automatically 10. A natural log is always e. Can't be anything else. Okay, so we have log. The base of z becomes the base of your log. The answer to the exponential equation becomes your of part, and then the exponent becomes your answer for your logarithmic equation. All right, so now we're at a point where we have 13 through 16 left. Please try those on your own. Pause the video, try those problems, come back and see the answers. All right, so hopefully you've tried those 4 questions, and then you can just check your answers. I'm going to go through these real quick. Again, this is an e, so it has a natural log. So it should look like this. We have natural log of t is equal to 4. Next one. We have log base 5 of g is equal to 2. Log base x of y is equal to 1/2. And log base s of d is equal to a. Okay, so this is the end of the first part of the notes. All right, please watch the next video on expanding condensing logs.